The double slit experiment is a classical experiment in physics that you might have learned about in high school. The way it works is we take a wave and we pass it through two openings, or slits. In doing so, we create two identical waves that are completely in phase. As these waves propagate through space, they can interfere with each other, and they can interfere either constructively, so that they add to give a wave that is greater in amplitude, which is represented by these very bright bands we see here, or they can interfere destructively, so that the waves cancel out to give a zero amplitude, which is represented by the dark bands on this slide. So the resulting pattern we see here is known as an interference pattern, and it's very typical of the behavior of waves. Let's repeat the double slit experiment, except in this case, we'll use particles instead of waves. So here we're using bullets, and we're going to fire the bullets through the two slits. You'll notice that after we fire a number of bullets, we end up with a collection of bullets behind each one of the slits, represented by these two lumps. So you'll see that the result we get from firing particles through the double slits is completely different from the result we get when we pass waves through the slits. So when we fire particles through the slits, we get no diffraction pattern. Once again, we repeat the double slit experiment using particles. However, instead of bullets, this time we're going to use electrons as our particles. So as we fire the electrons through the two slits, we're going to capture the electrons that pass through the slits on the back of this screen. So after a number of electrons have been passed through the slits, this is the result that we get. As we pass more electrons through the slits, we get this result. And as we pass even more electrons through the slits, we get this result. So you might remember that this is exactly the same result that we get when we used waves and passed them through the slits. So what's shocking about the result is that bullets behave like particles, however, electrons behave exactly like waves. However, if we repeat the experiment and we force the electrons through one slit or the other, we lose the diffraction pattern and we get exactly the same result that we did with bullets. And if we try to repeat the experiment with electrons, but this time we try to peek to identify which slit the electrons are moving through, we end up losing the diffraction pattern and getting exactly the same result we did with bullets. What's significant about this experiment is that simply the act of observing the experiment changes the result.